Uh, the next speaker is Shinsuke Abe. He's going to present the topic Annual Variation of Sodium in the Geminid Meteor Shower.
Okay, good afternoon, everyone. My name is Shinsuke Abe from Japan. So, can you see my, okay. Here is today's topic. So today, so I concentrate on sodium spectrum. Sodium is one of the perfect indicator to investigate the volatility within the meteoroids. So in this topic, I will present about the Geminid Meteor spectrum over 6 years and over 500 spectral analysis result here. Okay, so review of the Phaethon Geminid complex. So-called PGC. So Phaethon displays comet-like activity with faint tails existing more than 250,000 kilometers from the nucleus. It was discovered by the solar monitoring telescope and brightening near the perihelion. And associated with gas emission was also indicated. And the Phaethon surface reaches temperature was estimated almost about 800 Celsius at perihelion, 0.14 AU. And moreover, JAXA, I'm a member of Destiny Plus mission, will be launched in 2025 and flyby of Phaethon in 2029. So it was delayed for 1 year, but arrival year is still the same. And so surface sufficient for the thermal decomposition and the volatile emission from chondritic mineral phase was proposed by this paper. And the decomposition mechanism and which specific minerals are caused observed Phaethon's emission are still unclear. So sodium in Geminid meteoroids provides additional information on origin and evolution of PGC. So I will explain in detail here. Okay, so thanks for introducing the same camera, Sony Alpha 7S. So we are using the same camera and with IR filter and without IR filter. So we have basically using the two kind of lenses, Sigma or Canon 35 and 24 millimeter lens, which correspond to the 63 or 84 diagonal field of view. And the spectrograph is provided by Edmond, it's commercial one, VIS 600 groups per millimeter. So we just made the holder and put the spectrograph in front of the lens. So this is a way to observe the meteor spectrum using the UFO capture to capture the video 4K uncompressed image and recording with a relatively high-spec PC. Okay, so I will explain the analysis first. So here we, of course, dark and sky subtraction and flat fielding, and we obtained flat fielding with camera and lens combinations each other. And we also took the such chart to calculate the distortion correction equations. And in this study, we are using two kinds of gamma correction. So we have to care for the gamma for our observation. So here is the input and y-axis the output. So usually it's not linear. So we have to consider this curve for the very precise calibration. So for example, we strongly recommend S log 2 in order to avoid the saturation for bright meteors, and also faint meteors can be detectable using S log gamma function. So those equations are provided by Sony on internet, so everyone can see the conversion equation on internet by their white paper. Okay, so another important thing is that the sensitivity curve. Sensitivity curve is a function of incident angle. So we are using a relatively large field of view camera. So in the laboratory, actually this is my room, we are using 1 degree step rotational stage to get these RGB spectral sensitivity for each camera and each lenses using the calibrated light source. So using this set of RGB spectral sensitivity, we use the sensitivity calibration. And moreover, for example, the Geminids, we have a background component caused by the sodium molecular nitrogen from the atmosphere. So we have another model to fit the background using the electron vibration and the rotational temperature to fit each spectrum to subtract, especially for the sodium region has a small component of the nitrogen plasma. So we care for these calibration. Okay, here's a real-time analysis video, what we are doing. So we made a special software so-called Hokulele, which means Hawaiian, in Hawaiian language, meteor. So we are subtracting sky background and flat fielding, distortion correction and gamma correction, and tilt angle correction, and pixel wavelength conversion, and nitrogen background subtraction, and finally multi-Gaussian photometry, and combined one into the one spectrum in FITS format or bitmap formats. So this is a way to analyze, and to get the more than 500 spectrum in the same way. So if you are expert, you can analyze one spectrum within 20 or 30 minutes. So before using this software, it takes about 1 day for one spectrum analysis. So we can reduce a lot of time. So that's why we completed more than 500 spectra in this presentation. Okay. So here's a summary of obtained spectrum so far. Since 2017, we have a campaign observation for Geminids, collaborating with amateur astronomers. And basically, we have 2 or 3 locations in Japan, so according to the weather condition. So each year, the number of the detected meteors are different because the weather conditions are different. So here is a definition of sodium content. Less than 10% is sodium pure. Between 10 and 30% is sodium normal, and more than 30% and less than 80% is enhanced, and more than 80% is sodium rich. So I will explain more in detail in the next figure, but as you see, the sodium pure is getting smaller with increasing the year. So I will show in another plot. Before explaining, I will show the real spectrum of Geminids. So here is left-hand top panel is sodium normal. As you see, magnesium, iron, and sodium are the normal meteor. And sodium pure, sodium is very weak, and sodium free is almost nothing. And there are also extraordinary spectra, like iron spectrum, iron Geminids, and iron pure Geminids. So here is one of the examples of iron spectrum coming from Geminids. Okay, so we already published one paper summarizing 2017 and 18. As you so here is we call Ternity diagram. The intensity ratio between sodium, iron, and magnesium. On each point, plot indicate one spectrum, one event. And this solid line shows that the chondritic material with the entry velocity. So after 40 kilometers per second, because the speed is enough to ablate, to increase the temperature for ablating for each element, so it's very shortened. So for Geminids, entry speed is around 35 kilometers per second. If it's chondritic, the point should be here. So we can compare with the location, compare with the chondritic material. As you see, sodium is depleted. So left part is depleted for sodium, and magnesium is relatively enhanced, and iron is also it's almost same as chondritic. But so it's 2070, 80, and 1920. the situation changed dramatically, and sodium variations shows has more variety. So we are surprised in these 2 years, and then next year it's sodium. So we cannot observe such many sodium per spectrum. So we recompute again and again using several students to get the same results. So this result is real. So from now, I explain several hypotheses to explain these results. Okay. And this is also the plot of sodium ion intensity ratio as a vertical line, and the horizontal line is ecliptic solar longitude, and the dashed line is the Geminid maximum. So these are observed point. So there is an observational time bias. And in 2017-18, most of observation was done before Geminid maximum. But 2022, we observed just after the Geminid maximum. And 2021 is far until Geminid maximum. So there is such biases. But anyway, we can see a weak trend. The sodium content is getting higher with ecliptic solar longitude. So which indicate probably after the Geminid maximum, sodium content is higher than before the maximum. And recently, one paper was published by Tomasz Hennicky, and so in this plot, so aerodynamic pressure distortion distribution versus initial mass of the Geminids are indicated. So here is a number. These numbers and colors designate the percentage of the entry mass destroyed at a certain aerodynamic pressure, y-axis. So if you see here, so the number G4 fireball, about 84% mass was designated at a pressure of 0.56 pressure. So you can see this trend here, and also a larger mass trend here. So we can investigate probably smaller grains is more weak or fragile. And E.G. Borovichka also published in this paper. He analyzed same way using the very precise light curve to fit his model to show the grain size of Geminids. So most of the normal Geminids probably between 80 to 300 micron in diameter, but larger meteoroids here, Geminids macroscopic pieces between 1 to 10 millimeter shows increasing with its grain size. And more than centimeter size has no fragmentation here. So about the grain mineralogy, so probably I have not enough time. So there's some sodium-bearing minerals from nepheline or sodalite from CM chondrite. Probably so this is a sodalite. Probably if I can buy this sodalite, which may give me the idea of deep insight of sodium variation. Okay, so here's a summary. I have one more slide. Sorry. So probably this yearly variation is caused by the particle was aged, solar heating aged across the stream, parent meteoroid stream. And Galina also mentioned about the mean orbit Geminid stream are gradually approaching to the Earth's orbit. So we have to think about the size bias. Also, different part in the dash stream has different contents of the sodium. And finally, I want to call about the Phenicid spectroscopic observing campaign. So in Japan, so next sample return target is Brampton. So Brampen is a parent body of Phoenices, and Phoenices has some prediction for small activity on November this year, November 14th. So please take picture and please collaborate with us. So JAXA asked me to get the information of spectroscopy. So they need more compositional information. So because ground-based observation of Brampen is so poor, so they cannot get the information from the parent body directly before launching. Launching date probably 2030 or 32, I don't know. But yes, so this is the campaign. Okay, thank you.
Thank you very much.
What day of the week is the 14th of November? What day of the week?
It's a weekend. Yeah.
Okay, there is a question here written by Peter Brown. He mentioned, have you plotted your sodium abundance as a function of the original Geminid meteoroid mass? Could the variation in sodium be a mass-dependent effect? I guess you mentioned it in the last slide.
In my spectroscopy, most of the spectrum were brighter than 1 or 2 magnitude. So there is a bias for the size in my inner spectroscopy. Within this size, there is a huge variation over 6 years. So this is the result.
Okay, I see more questions.
And size dependency is still uncertain. We are doing trying to get more precise photometry to see the size dependencies.
Okay. I see more questions. We have only time for one, so I would give it to Galina that she's online, and you have the question, then the chance to discuss it with Shinsuke in person. So please, Galina, you have raised your hand. So please go ahead.
Thank you. Shinsuke, hearing you, you told that properties of Geminids after maximum is a little bit different, yes?
Yes.
And I found my old presentation, and according to my old model, but it should be checked, Geminid after those Geminis which registered at the Earth after maximum were ejected from parent body after perihelion. And those before maximum, before perihelion. I don't know now how it agree with